So, very good morning, and I'm KONNI from Petrofac, and hopefully you will enjoy the session, and end of the day you will take some good takeaways. Let me make sure that. So, this is about, I'm going to discuss about two case studies, and we'll have, I will try to, complete my session about 1 or 2 minutes earlier, so that we'll have more interactive session, wherein I may also get some takeaways. So let's not spend much time on this. Now, what is the case study one? Thus, this case study one is, we have one project in Turkey, where we need to build a gas receiving terminal. Gas is coming from Russia through a Black Sea. This is the aerial photograph of the project, which has been built. Let us not spend much time on that. Let us move on to the content. So what is the context? The cut fill foundation philosophy in unforeseen soil conditions. There is a change management. I will give you more about that in the next few slides. Complexity is, there is a massive cut and fill. When I say massive, I'm talking about 300,000 plus cubic meters of soil to be cut and filled. And what happened? The soil, initially we thought the soil is okay, can be cut and reused to construct the embankment or the platform. What happened during the project stage? That is where the challenge started. And impact will be on the project schedule and also, of course, the CO2 emissions. We'll talk more about it. Now, let us see the topo of the site. This is in Turkey, located in a steep mountain, lot of trees. There is a huge variation in the topo. Let us see the cross section. So one side is existing ground is plus 65. The downstream, the deepest is about plus 45. This is the steepest terrain we had, wherein we need to have a leveled platform, which involves demands excessive cutting and filling. Right? Now, let us see. Now, this is the profile. The left side one is the cutting, and right side one is the filling. The initial bidding stage, the idea is the complete soil which is being cut can be reused to develop the platform. That was the idea. So that is the reason what we do generally in order to avoid more vehicle movement or importing and disposal of the soil, we always make a balanced level of the platform so that we can minimize the earthwork movement. That's how the level of plus 57.8 has been derived. Perfectly all right. Then, based on this assessment, what was the cut soil is about 350,000 cubic meters to be cut. What is the fill? Around 355. Till here, everything's excellent. So do we have a feed geotechnical report during the bidding stage? Answer is no. Why? Because this is a very mountain area, lot of plants. Probably, client would have an option to go there and do testing. But they have given some rough borehole data, which is quite far away. Based on that, as a Petrofac need to develop the foundation philosophy. Client said, it's okay, soil is a granular soil, go ahead. Of course, we have proceeded accordingly. Now, project is awarded. Here, the investigation during the project stage was under the scope of client. So they have done the investigation. They have shared the report. What happened? The scenario is completely different what we assumed during the bid stage. The bidding stage was granular soil, pretty good, dense, very dense, perfectly all right. But when we have gone there, testing was performed, the data revealed that the soil is completely different than what you can see here. So you can see the physical parameters. The fine content is in the range of around 60 to 85%. And the liquidity limit is about 33 to 80%. And the plastic limit is around 15 to 20%. Definitely the plastic index is very high. And the question here is, can we use this material to construct that that platform? Definitely not, right? Because this material, clay, how can we use to prepare an embankment? Of course not. Because it does not meet the specifications, it is not compactable? Of course not. So, let us move here. Then what happened? I have written a communication to the client, guys, what you said before was no more valid. Now the situation is completely different. Completely clay soil. We cannot reuse this material. The client said, no, I don't have time because already the gas from Russia, the pipeline is already constructed very close. I cannot extend the time, guys. Fortunately, it is not a lump sum project, it's a reimbursable project. So we have an option to think about it. So the question is, if you see assumed by P, it is a Petrofac, the majorly the cohesionless soil, of course good, reusable, compactable. What has been revealed is majorly a cohesive soil. Just I have shown you. The second, the soil cut soil is suitability, the assumption was yes during bidding stage, now actually not. There is of course, being a clay, there was a swelling potential as well. What does it mean here? Why I'm saying so much about this? Okay, soil is not suitable, you throw it, bring a good soil, compact it, go with the foundation system. That's what we generally do, right? But I am putting here. So this is the communication given in the year of 2020. Now, what are the engineering conclusion based on the information what we have received? The site cut soil is not meeting the project specifications, not suitable for engineering applications, of course. Now, what are the concern? Okay, not suitable. So what is the concern? About, I already told, about 300,000 plus soil is to be disposed. A similar amount of soil has to be imported. And the borrow pit was identified to be around 70 kilometers away from the site, which was not the case during bidding stage. Then, as per my project director came, because the client is pushing a lot, no way, there is no extension for the time. The tentative estimation was showing that we need 1 truck of soil for every 6 minutes from 70 kilometers away to meet the project schedule. Is it really possible? To me, no. Because the amount of soil required, every 6 minutes 1 truck, how many vehicles I need to deploy? And there are very kacha roads, narrow roads, villages. Is it really possible? Answer is no. Then how to live with this? It is already we discussed. Project schedule is fixed, no way to extension. So now, of course, many of you thinking, what could be the solution so that the project can be completed within the schedule? I know you people are thinking something. I also thought the same thing. What we have done, I told you this is not a lump sum project. It is a reimbursable project. So I have a flexibility on the cost. So what we can think? So let us assume that there is a site where already clay is there. I'm not going to remove all the clay, right? I'm going with the pile. So I said, okay, let us use all the cut soil and fill it here. Instead of shallow foundations, let us go with the piles. That is how the complete soil which has been cut, though it is not meeting the criteria, though it is not a compactable, I reused it, instead gone with the piling. I make sure that my foundation system is perfectly all right. Performance is okay. So that is how the solution has been given. The piling has been provided. Now, so you can ask me question, okay, up to foundation is fine. What about the clay mass that you are filling here, how it is going to behave, and also what are the slope stability issues? Then what we have done, we try to isolate the complete mass from the soil ingression. So we have provided, you can see here, the lower, there is a drainage layer, it's very slopy. We avoided the capillary ingression of the soil into the water into the soil. And the top, again we have provided HDP liner with the geotextiles. Any water from the rain goes away. Again you can ask me a question, is it 100%? Answer is no. Why 100% you need? My foundations are perfect, let some water go. I cannot ensure because when I'm doing a piling, definitely the HDP layer will be punctured. Let some water go, what will happen? So that is how the solution has been given. Now outcome is, it is very innovative at that point and fit for the project. And in fact, project is completed 15 days earlier than the actual schedule. So these are some environmental benefits. This is about economical benefits. Is it all? Answer is no. There are some additional quantitative benefits which was not even thought of. It is revealed that, of course, it is an environment-friendly solution. Now, about 30,000 tons of carbon dioxide emissions have been avoided. How? Because I have avoided the utilization of the trucks and the excavators and the wheel loaders. And also about 9.8 millions of diesel energy has been saved. So I have presented a paper in this conference, one of the conferences. I have just extracted those figures from that conference paper. I have given the reference as well. So takeaways, site cohesive soil should not automatically be treated waste. With the proper categorization and treatment, cohesive soils can be successfully utilized. Performance-based design and construction control can make a reuse of technically viable and environmental preferable solutions. Now, I think now I will move to the case studies too. I think only 5 minutes left. So this is about the optimization of the pile foundation for one of the projects in UAE, that is Jadco. We have 4 islands. So island fill contributions shall be ignored. The design philosophy is very clear. The island fill shall not be considered in the pile capacity. Negative skin friction shall be considered. Pile compression capacity shall be derived only from the rock socketing, and no end bearing shall be considered. That is the ADNOC specification says, which we need to follow. So these are the summary of the data. Usage around 7.75 to 8 MPa. Average is around 3.6. And design uses 2 MPa. And design unit skin friction is around 200 kPa. This is what initially our design consultant has considered for his design. So where is optimization then? Now, just there are 2 parts. There are 2 contributing factors for the design optimization. One is advantage of existing pile load test. So you can ask me, when did you do the test? I have not done the test. Fortunately, in the same island, one of the islands, the previous contractor has done some load testing. I have taken that data and tried to use that information and convince my consultant to push a boundary a little bit so that we'll get some optimization. Now, what we have done, what I have done in order to convince this design consultant. So we have just used all the available methods to estimate unit skin friction from the available UCS data. If you see that let me go there. So this is a curve which has been proposed, this FSAW method, which is very lower than rest of the approaches. This is around 200 kPa, the unit skin friction, which has been initially proposed by design consultant, which I am not very happy. Yesterday also we discussed about optimization and all. Now the gap between the horizontal lines, there is a load test data. If you see the gap between this is around 590 kPa. Design value is just 22% of actual measured UCS. Sorry, skin friction. Now what I have tried, the optimized value, I pushed a bit and moved up to 290 kPa. Still, I'm not saying that we have done a lot of optimization. Because this guy has given low, we pushed a little bit more. But for me, there is still room is there. So this is the around 30% of measured value still. Now second is probably interesting, the negative skin friction. But generally what happens, that traditionally, the negative skin friction shall be considered in the pile design, which means the negative drag force shall be deducted from the pile capacity. I say no. Because that is not a geotechnical problem anymore. Not all the cases, in specific cases. Probably you can see Professor Fellinius publications. When I was doing my PhD, we have invited the professor, we have worked together, we have done a lot of pile load testing on the instrumented piles. Eventually, there is an outcome that yes. So what we have done, we have not considered the negative skin friction in the geotechnical capacity. Unfortunately, we don't have much time to discuss. We can discuss off stage. So then, that amount, it's not saved much, about 0.5 meter per pile has been saved by this. The remaining is from the load test data. So excessive pile drag shall be checked. There is a case where there is a negative drag coming from the negative skin friction. That may not be the problem of geotechnical. However, may be problem of structural capacity of the pile. Because some load is coming from the structure. In addition to that, my pile is being dragged or pushed down by the negative drag, which may exceed the structural adequacy or capacity of the pile. That has to be verified. So now what is the result of this optimization? So these are the 4 islands. Probably you can see this is the initial pile length, reduced pile length. You can see the table left side. The total, there are 4 islands. The total pile length saved is around 18.4 kilometers, which has resulted in about 8,000 cubic meters of concrete saving. And also drilling is avoided. It's offshore islands. You know the logistics, moving a concrete or steel, cages, etc. It's very expensive. So definitely it is very important, and it saved about few millions of dollars, by the way. So this is how it has been done there in the island. Now factors, now let us see, sorry, I am already late, but I want to just request the team. Since yesterday we were discussing about optimization, over conservatism. Let us just, I added this slide today morning to discuss. No, sorry, uncertainties in the subsurface conditions, inadequate ground investigation. Is it in our control? Answer is yes. We can convince the project, we can do more testing, probably we can get what we need. Now what is the next contributor? Unavailability of the full-scale pile load test data at the time, because always a preliminary test piles we propose, we schedule, but unfortunately we cannot do because of time does not permit, and we need some time to refine the design and all. It's not our control, not 100%, Generally, project schedule controls, we'll discuss more about it. Experience or engineering judgment of assigned design engineer. This is very important. This is a contributing factor because some guy who is doing the design, if he's not expertise enough, he's very junior guy, he will take very low value. Once he has taken low value, though it is a X company which is very famous, when the report has come to the client, you go and ask him, he will not change because there is a reputation. These matters, who is the engineer, who is designing, what are the parameters he is taking, whether they're okay or not. That is also one of the contributing factors what I have seen in my journey. Benchmarking previous projects. Now, for example, we have an island work project. One phase is completed. When you do the second phase, we have a lot of data. We don't use it. Our PMC guys, our clients, everyone say, no, why are you doing that? You see the previous project, what you've done. Go with the same way. That is also benchmarking the certain things, which is not allowing us to kill or reduce over conservatism. The proper logical consideration of NSF is recommended. Existing pilot test data is very helpful to reduce the degree of conservatism that is built in. I know generally project schedule does not allow the exercise of refinement. Instead, alternatively, is there any possibility to think on using existing pilot test data, preliminary and working from the previous phases or nearby projects, which may help us to think over. Using existing pilot test data from the previous phase of the project, that also can be considered for this project to give an idea wherein we can just push our boundaries a little bit so that we'll get a little benefit. Thank you very much.